Okay, Assalamualaikum and good afternoon. How are you today?
Good, sir.
Salam, sir.
I'm sorry for the last Monday. Kunci saya tertinggal dalam kereta. Jadi kereta pun terkunci di luar. So berjam lah nak selesaikan masalah tu. So at the end, I don't have any choice other than cancelling the class lah. But kelang kabut tak sempat. Okay, I think I just proceed. Okay, this number 42. Okay, we have started last week's Wednesday about the standalone or off-grid photovoltaic OGPV. Okay, OGPV pun boleh. OGPV, not OPV but the OGPV, off-grid photovoltaic. Okay, ataupun SAPV, stand-alone photovoltaic, boleh lah mana-mana. Okay, we have learned about the energy demand and so on. So I just continue from there. So most small standalone PV system, especially solar home, use 12 volt as the battery voltage. Okay, battery voltage, basically they use the 12 volt DC base battery. Okay, so this is the system voltage. This means battery are configured at 12 VDC and the charge regulator and moderator are rated at 12 volt DC. Ni the what we call it above regulated lead acid, VRLA, AGM, all the lead acid battery lead acid battery. The nominal basically is 12 volt. Okay, 12 volts. But it's not the 12 volt 12 point something Even though after you charge also it will rise up until maybe 15, can go to 14.7, 14.8 or 15 something. But the rated one, the nominal value is 12 volt. So all the system will be based on a 12 volt DC system. Okay. So sometimes 24 and 48 volts voltage is used. That's why this one what we have discussed before. This one from 1 kilowatt hour to 1 kilowatt hour until 4 kilowatt hour. And for 48 volt DC system, more than 4 kilowatt hour. Okay. In such cases, battery and solar module are wired in series or series parallel. So that's why this come the series, it come the series parallel and so on. When you connect in series, this is battery. Assume this is battery. Then we connect in series, 12 volt, 12 volt, 12 volt, and 12 volt. Then you're going to get the 48 volt DC system voltage. Okay. Then if we want to increase the capacity, so we just connect it in parallel. Means that, for example, if for single battery is 100 Ah, so if you want to get the 200 Ah original capacity, then you add another 4 in parallel. Okay, in parallel. And during the connection of the parallel also, you need to be very, very careful Please use the breaker, so that if you don't use the breaker while you try to connect, the the one series and one series, you try to parallel it, it may not explode. It may spark some sparks It may produce some sparks during your installation of the battery. So that's why when you're playing with the battery, please make sure that you use the glove, the insulator based glove, not use the wrench. Please don't use the wrench or the spanner. Wrench. Ni range. Dia tak ada rupa. When you try to open the, the bolt of the battery kan, please make sure you use glove. If you want to hold it with glove that made by the insulator material lah. Insulating material. I think maybe clothes, fabric also okay. Maybe fabric okay, and rubber, okay, rubber base. Or if you don't have that kind of glove, then you use the tape, the black tape, yang tape hitam, yang selalu orang wire, taping the wire. Kalau wire you strip the wires, you strip the insulator of the cable, then it comes the raw wires kan, copper wire kan you balut dengan with the black tape. Boleh juga you letak tape tu, you ikat kan, so that when you touch it, it's not conducting it's not conductive. Okay, so while adjust the bolt of the on top of the battery dari dua kan, plus minus tu kan. Faham apa cakap ni? Bateri yang di bateri 2 yang di bolt kan. So why you try to range ni ni kena make sure you don't touch it with your bare hands. Okay, don't use your bare hands. Mungkin kena renjatan, I'm afraid. Takut kena renjatan. So many charge regulators or charge controller and inverters that can operate at either 12 or 24 volts. Okay, 12 or 24 volt. They sense the system voltage and adjust to it automatically. Okay, when you try to after we have learned this subject, and maybe some of you has has interest to install your own system in your home, at least a small, maybe you buy the 100 watt of panel, and then you buy maybe 40 Ah of the battery. So you try to connect it, and you buy the charge controller. So make sure your charge controller tu you don't make mistake I think most by default 12 volt 12 volt charge controller, for example, by default they can support 12 volt and 24 volt by default. Okay, by default. Biasanya dia ada by channel lah. Dia boleh 12 and boleh 24. But sometimes they only rated for 12 volt. Okay. Please make sure you read it carefully. Sometimes inverter or charge controller, sometimes only 24 volt, 48 volt very rare lah. Sometimes they can do both. Ada inverter yang boleh 12 volt atau 24 volt channel boleh. But certain inverter they only support 24 volt. So the problem is when you try to use the only single battery of 12 volt, you cannot operate. That's why we try to buy it, make sure you read it carefully Terutama yang you buy online kan. Buy online tu you kena baca betul-betul lah. Kena tanya, kena confirmkan betul. Baca review bawah tu betul tak 12 volt atau 24 volt. Don't make mistake. Okay, same goes to the charge controller or charge regulators. Also they have rated. By default 12 and 24 volt. If you plan to plan the system more than 4 kilowatt hour, for example, then you need the 48 volt of system voltage. So at that time you have to make sure that your inverter can support until 48 volt. And make sure inverter and also your charge controller. Okay, make sure if you load more than 4 kilowatt hour, so make sure CC, charge controller and inverter to support 48 volt. Support 48 volt make sure. Okay, don't make mistake. Okay, this one of the general limitation is that the maximum continuous current being drawn from battery should be no greater than 120 amps for the single battery, but I think there's a rated for that. If I'm not mistaken, tak ingat lah apa lah. Dia ada size dia. Kalau lithium ion battery, if I'm not mistaken, 3CA. 3CA means C is capacity. So if the battery is 100 Ah, then it can discharge maximum for 3 Ah. 3 amps, 300 amps for the lithium ion. But for lead acid, they write here 120 amps, but still you need to make sure, please check again the data sheet. I think they can, most cases we don't use until that level lah. 120 amps too big. I think 30 amps also already high enough. I think normal breaker in your home also sometimes 40 or 50 or 60 kan. Tiba you guna sampai 120 amps, tak logik lah. Besar sangat ni. Confirm battery lagi cepat habis lah. But for the mega scale, I think that's logic lah. They use lot of current. Okay. Can you hear me? Ada ke orang? Orang ada ke kat situ?
Ada, sir.
Ada. Ingat. Wajib kau buka kamera lah. Nak buka kamera. Okay. After that, then we go for the daily system charge requirement. Okay, the system charge requirement, it's very easy. Divide the revised daily total system energy, blah blah blah. This is the loads that already revised that we have learned last week. Yang total demand tu. Alah, aku pun tak ingat dia punya equation apa. Load DC, EDC plus EAC over inverter efficiency and system efficiency kan. So that total, the total up, okay, is the required daily required daily energy requirement, okay, by the system voltage SV, not supervisor it's a system voltage, because supervisor is for pure to get the daily system charge requirement in M hours, okay. This is the charge in M hours that the module will have to provide each day to meet the load requirements. So we need to divide it with the system voltage that we have chosen already. It must be tally lah. If our load is 4 kilowatt hour, then you need to use 48 volt. If our load is less than 1 kilowatt hour, then system voltage enough for the less than 1 kilowatt hour. SV is 12 volt. 12 volt. Okay. If more than 4 kilowatt hours, so 48 volt. So means that all the we get here divide with the system voltage. So what will happen if you mistakenly choose the wrong system voltage by your careless, for example, so it will start to affect your marks from here lah. Lepas ni dia ada susulannya. Once you make mistake here, so it's going to be disaster after that. Okay. So we will divide by the SV, then we are going to get the M hours. Okay. The unit is AH. So it means that this is the charge in M hours that the module will have to provide each day to meet the load requirements. So after we divide with this system voltage, so you're going to get the ampere hours. The ampere hours. How much AH? How much ampere hours that you are going to need to use, or your system need to supply you this kind of energy. How many? So AH capacity to energy capacity is AH per day lah. Okay. So dia dah akan dapat AH per day. Okay. So we finish until the daily requirement daily charge requirement. So every day we know already that we need to use 300 AH for example. So my necessity for my system, I will need 300 AH per day. So this is the energy requirement that we need for every day. Okay. What's next? So next, check which month as the lowest mean daily insertion or daily irradiance. This is called the design months and used to size the array for standalone system. So kita panggil ini sebagai design months. Most of grid system are designed for the months of the year with the lowest insulation so that when the sun is least available, the system will work. So this is very important to have the historical data for the place that you are going to install. We need to have the month's data, the monthly or the yearly data of the area, then total up the PSH per month from the last year. For example, we want to install in this year, 2022. So you need to have the 2021, the data for the 2021. Okay, or any prediction, but the better one is historical lah, but you are going to get it correctly lah for the last year. So that's the pattern. So basically, there will be months. For example, in Pantai Timur now, we are having heavy rain, several typhoons, and lots of rain falls, and very less sunny days. Okay, today start to be the sun start to rise very well. But for the past several days before, so we are having heavy rain and some flood. So lots of total up, maybe for the December, maybe slightly lower than other months. For example, this data also just the simple. I don't know, to be honest. I don't know which country is it, which state is it. But the most important thing is to find the design months. So design months is where the lowest PSH, lowest value of the PSH. For example, here for the case of this, I don't know which data is it. Is in July. So our peak sun hours will be based on this July 4.5 hours. Even though we are going to get this is the average per month. For other months also can cover until maybe you see from here 6, 5, but only that month. Not by luck. From the historical data, then you get this month is the lowest one. So we are going to base the design based on this month, 4.5 hours consideration lah, not by the 6. So overall, when you do the design, there will be no problem. Inshallah, there will be no problem for other months lah, because other months higher than that. So kita taking the worst case lah. So we are taking the worst case, the worst months, then will be based on that value. Okay, so survey of solar resource and the selection of PV modules. So that's why this data, then you need to have the data meteorological. You need to ask the meteorological department in the state meteorological department, or we are using the PVCs, and the PVCs you can generate the interpolation of the value. It can be generated, but that one is the predicted one, not the exactly the real data. From the software also, that one also what's that? PVCs. Okay, PVCs. This from the software, so we can generate that kind of data lah, PSH per year. Okay, on dedicated location. Okay ke? For Chia Hui, is it okay?
Okay, sir.
Tak tidur Okay Nuraini, okay. Ini nampak saja. Nuraini.
Okay, sir.
Okay Aliza, okay Aliza.
Okay, sir.
Okay. Okay, proceed. So next is the sizing and installation of battery and PV module. Macam biasa saya nak kena ambil awal juga hari ni sebab ada meeting sekejap lagi. Okay, there are several calculation to determine the system sizing. One is the PV module sizing and the other is battery sizing. First of all is the PV module sizing lah. PV module sizing. Okay. For example, just take it from somewhere, but I put the citation there, which gambar I take. Okay. For example, they have the kind of panel specification. Maybe from here you can see this is polycrystalline. Okay, polycrystalline. And just an example of polycrystalline. Let's say we have the power output of the 100, and then MPP 16, and we get the IMP is 6.25, and get the VOC of 20, and IC is A. So, maximum power point tracking. Okay. The first calculation here that we're going to get from here is we call that minimum watt peak. Okay, peak. So the minimum one would be based on the total energy demand that you get just now, the revised daily, the what we call it, energy revised daily kan. It's actually 4.5 kan kat sini, tapi tulis 4 pula ni. Tak apalah, kita anggap 4 lah Patut 4.5 kalau tengok susulan daripada apa nama tu, susulan daripada example before lah. Tapi tak apa, it's okay. We assume that it's 4 hours. Okay, that I told you, typical case in Malaysia, we can put 4 hours lah, considering that they have the maximum 1000 watt over square meter of the energy or the area irradiance that we receive in Malaysia by default is 4 hours. Okay, 4 hours per day. So in order to get the minimum watt peak of the module, so the necessary minimum watt peak of the module that we need to have is 745 is the total energy demand that we have calculated before. Okay, calculate before yang 300 watt DC, 300 watt AC tu kan. Okay, then you divide with the equivalent sun hours or PSH of the place. So here for this case we get 186.25 watts, means that in one day we need the energy of 745 watt hour or the hour load, considering how many hours for the device, first device, second device, third LED, fourth LED yang we have calculated before, and by considering that we what we call this, our system can be feasible to generate the energy for hours kan. Sebab kita assume contohlah from 11 to 3 or from 10 to 2. Okay lah, 11 PM to 3 PM is the maximum. Most of the cases, most of the sunshines are concentrated on that time period. So that's why 4 hours. Then our panel, we need to have the power, the minimum watt peak of the solar module is 186.25 watts. Okay. So if we try to use this module, like I told, this module is 100 watts, means that you just simply 186.25 watt, you divide with the rated power of the module that you are going to use. If for this case is 100 watts, so you just divide it and you get 1.86 blah blah blah, and that you round it up 2 panels because minimum lah. We need to have 186.25, but minimum, so means you cannot cut lah. Second one you cannot cut to become 86.25 kan, mestilah kena panel yang, so that's why we round up, then that's why we get 2 panels. So our system, from our energy demand, that we need 2 panels of solar module. 2 pieces of solar module lah, of 100 watt. If we have the 200 watt solar panel, solar module, then it's enough to use one only, because 186.25 over 200, you get 0.8 something. It means that one lah. So we need only one. And if you use the last time I show you the several modules with the mega size, with the size, the big size, 550 watt per module. So if you use that, it's over lah kan, over. Sebenarnya you need only 200, 186, tapi you guna yang 500 watt lah. So dia rugilah di situ, rugilah kalau based on demand. In order to avoid that rugi, that loss, so you can increase energy demand lah. You can multiply lagi lah energy demand tu, sebab kita beli modul yang besar, 500 watt contohnya, 550 watt, besar betul. So tambahlah lagi energy demand, but in the same time you need to consider for the additional batteries. Tu dia cerita dia. So ini here, then we can get the minimum watt peak of the panel that we need. So we get 186.25 watt, but the number of panels that we need is 2 panels. By using this kind of module lah. Ini, kalau kita guna modul ni, so kita perlukan 2. Boleh? Senang je ni. Atikah Nurdin, boleh?
Boleh sir.
Faiz Saleh. Understood?
Yes. Okay, sir.
Easy easy. Not too difficult lah, easy.
Yes, yeah.
Okay, I proceed Okay. Alright. Since E required daily 745, I'm still using the same example from the beginning. So I still use the 745 watt hour of E required daily or E required daily revive, whatever lah, the energy demand that we need. By after consider all the efficiency of the inverter and system efficiency, and so we get what 745 watt hour. The recommended, we know already, the SB system voltage is 12 volt. This one no argument. Okay. But another thing. Therefore, since the modules VMPP or VMP, whatever it is, okay lah, ni boleh tukar ni pula, Vmax ke VMP ke whatever lah, is 16 volt, which is greater than system voltage of 12 volts. Only one module is connected in series. I repeat, since our module, the VMP of this module, VMP is 16. Okay, 16. It is greater than the SV of 12 volts. Only one module is connected in series. The rest of the modules will be parallel because we have two modules. We calculated just now. We get two panels, okay, two pieces of solar modules, and then our VMPP is greater than the SV. Means that 16 over then 12 volt. So one module is enough, it's connected in series. The rest will be parallel, but the total power is still the same. We are going to supply 200 watts in total lah. So means that our arrangement of the modules will be like this. Okay. One series and two parallel. This one 100 watt, this one 100 watt. Then here come the CC lah, charge controller after that. Of course lah, you need to have the, okay lah, kena ada fuse, okay, fuse here, and then breaker, DC breaker and so on. Okay, boleh? Okay, my question, what will happen when we do this kind of, when we construct this kind of arrangement? What will happen? But what will happen? Tanya siapa? Syahdan.
Yes, sir.
What will happen to these modules? Apa akan jadi? Once kita buat macam ni, apa yang akan jadi? Apa efeknya? Apa efeknya? Bila kita one series and two parallel, apa akan jadi? Kau fikir je lah, kau fikir je lah macam mana jadi apa dekat datang. Apa jadi? Boleh connect lah dengan benda-benda lain ke? Contohnya, bila kita dah parallel ni, apa yang akan jadi sebenarnya? Apa yang hasil terasa ni apa jadi? Output ni jadi macam mana? Ada idea?
Tak ada idea, sir.
Tak ada idea. Contoh saya tambah sikit. Okay, 16 volt ada, lepas tu kita parallelkan dia. Contohnya berapa total voltage dia, berapa yang keluar current ke contohnya. Bagi clue lah tu. Tak tahu? Ada idea?
Oh, tak ngakak lagi, sir.
Tak apa. Nakib. Muhammad Nakib.
Yes, saya. Dengar, sir?
Dengar. Okay.
Dia punya output power dia sama dengan input power. Kita
Okay.
dapat sebab dia parallel. Voltage dia.
Okay, lepas tu? Itu je?
Itu je lah.
Satu point kau bagi. Okay lah, boleh lah. Satu point. Betul. Input power sama dengan output power, betul? Masuk 100 watt, campur 100 watt, 200 watt, keluar pun 200 watt je. Okay, betul? Boleh diterima? Tanya orang lain lah. Lai Chong Jin.
Yes, total.
What will happen? What will happen? What is the effect? Once we do this kind of arrangement in parallel, what will happen? Your friend just now said that input power will be the same as the output power lah, sama lah. Apa yang masuk, itu yang keluar. Okay. Lain? Jeng. Tak ada idea?
Ya, sir.
Tak ada idea? Okay, tak apa. Tanya orang lain. Siapa lagi? Deva Rajan.
Yes, sir.
What will happen? Let's say we combine parallel tu jadi apa tu? Expectation dia akan apa? What's the output from this arrangement?
Not sure, sir. Maybe power distribute evenly to each module.
Power distribute okay, nak cerita input sama kot. Maksud okay. Power tu tadi orang dah sebut lah, orang lain dah sebutkan, tapi point lain. Selain daripada tu, input power okay.
Sure, sir.
Lain, tak ada. Voltage ke, current ke, apa benda ke, tak ada.
Tak ada idea.
Tak ada. Alright, tak apa, aku tanya orang lain. Firdaus Rosli. Firdaus. Hilang. Daus. Nampak macam nak jawab. Suara tak ada. Mic rosak pula. Ada idea apa akan jadi? Alah, susah lah kalau mic rosak dia tak syok lah. Ni cara sikit ni. Apalah saya tanya orang lain lah. Nafis.
Yes, sir.
Keluar. Siapa tu? Nafis ke siapa?
Nafis, sir.
Jadi apa ni? Apa akan jadi?
Voltage lebih, sir.
Voltage lebih? Kita sambung parallel. Voltage lebih ke?
Sebab dia cakap dia sambung series, lepas tu yang lain baru parallel. Tak tahu, sir.
Dia satu series je. Macam ni. Satu series, dua parallel. Sebab kita ada dua model tadi. Kan? So satu series ni macam ni lah. Dia macam ni. Lepas tu ini dia parallelkan, lepas tu sambung lah dekat dia punya charge controller tu. Tak ada dia. Awak sebut tadi voltage dia bertambah kan? Maksudnya voltage dia lagi besar kan? Jawapan dia tak lah. Tak apa. Seorang lagi akan ni. Lambat sangat ni. Okay. Siapa lagi yang betul lah. Jihan.
Kalau naik voltage sama.
Jangan ada bunyi lalat kan. Kau dekat dengan laptop ke ni?
Hello, dengar tak? Clear tak?
Ya, clear.
Okay. Current dia lain, voltage sama sebab dia parallel.
Betul. Voltage sama, current dia lain. Current dia jadi berapa? Tanya terus.
Dia akan divide by 2 lah kan? Sebab pasang dia parallel, tak macam tu. Allah, sorry.
Sekejap. Okay. Okay. Maksudnya kau, sekejap. Salah sebenarnya, saya ni sambungan sana. Sekejap. Tak ada kat ujung ni. Sorry. Dia macam ni. Alamak dia tak lawa pula ni. Aduh. Dia macam ni. Dia macam mana aku buat ni? Susah dia. Dia ada 2 wire sebenarnya. 2 wire, positif negatif. So yang ni akan sambung sini. Ini pula akan sambung sini. So dia akan masuklah positif dan negatif tu tempat charge controller kan. Okay. So ni kira macam positif dan negatif. Okay. Voltage dia sama.
Voltage dia sama, current dia different.
Current dia different betul. Current dia jadi macam ni. Dia jadi apa current tu? Kau cakap tadi half lah. Okay. Jawapan dia, current dia akan multiply lah.
Multiply, maksudnya kali 2 lah kiranya.
Kali 2, yes.
Okay. Faham.
Dah hampir kena ada tapi terbalik sikit. Okay. When we do parallel connection, sorry lukisan yang bawah tu agak buruk, mengelirukan pihak lawan. When we do parallel solar panel, then our system, our panel voltage will stay the same lah. Make sure we need to use the same module, same rated module. Don't use different. If you use different, then dia akan confusion sikit. Dia akan jadi confused sikit. Okay. Bila kita sama parallel, ada connector lah. You are going to use the connector or you use the kind of like bus bar, something like that. Then the current tu dia macam bateri lah. Current tu dia akan multiply lah. So once multiply means that because we are connected parallel to saya rasa sebiji tu berapa lah, tak ingat lah. Okay, 6.25. Okay, 6.25. Okay. Kalau satu modul, dia punya current dia 6.25. Dia dah buat panggil balik. Tadi okey. Ni yang stress ni. 12.5 amps. Expectation. So the current will be multiplied. So what will happen when the current, we call that charging current. So charging current, because usually when we have the CC ni bukan close contact CC ni charge controller. Okay, charge controller tahu kan dia ada sambungan dekat bateri. Okay, dia ada bateri bawah ni. Okay, bateri bawah ni, so the charging current will be increase. So bila charging current will be increase, let's say you have the battery of capacity 25 amp hours. Wah, dia dah buat panggil balik. Okay, 35 AH. So it will take for you 2 hours only for the battery to be fully charged. If it's in the peak condition lah. Maksudnya higher irradiance, current tu memang drive 12.5 aja for 2 hours straight. So within 2 hours your battery should be fully charged. Itu maksudnya. That is the benefits of paralleling your modules. Okay? Your modules. But remember 16 volt. Because the 16 volt is better than that, it's greater than 12 volt, then okay. But what will happen if your system voltage is 24 volts? Okay, apa jadi? What will happen if our SB 24 volt? Ya Allah, dia buat perangai lagi. Okay, tak apa, tanya soalan. Saya tanya Najihah. Saya nak tengok intact tak dengan kelas ni. Najihah.
Yes, sir.
Okay.
Dia kalau 24 volt Dia
Kalau
jadi
kata let's say kita punya SB ni 24 volt, kita nak buat macam mana? Kita ada 2 modules, kita nak buat macam mana?
sum up kalau dia double.
Double apa? Double current.
Double the value.
Double the value ah. Double value apa?
Doublekan.
Apa yang kau doublekan? Apa yang kau doublekan tu?
Dia punya module punya current tu.
Okey, modul current jap. Okey. Saya nak soalan saya, mungkin soalan saya mengelirukan. Sekarang ni SB kita 12 volt, tapi saya tukar. Let's say kita sistem voltage kita 24 volt dengan keadaan modul kita still sama. Satu modul 16 volt. Okey. Connection sepatutnya boleh tak kita buat one series direct to parallel?
One series direct to parallel. Boleh.
Valid lagi tak? Kalau kita punya sistem voltage bateri kita tu 24 volt. valid lagi tak connection ni? Satu series darab 2
Dia
parallel.
kalau dua tu sama kan sir? Dia kena sama modul 2, satu lagi tu bukan dia baru boleh multiply kat situ.
Okay. Sama modul 2, betul. Sama modul 2. Tapi let's say lah kita tak boleh tambah modul pun. Kita ada 2 biji ni je. Kita ada 2 biji. Tapi kita punya sistem voltage tu 24 volt. So, soalan tanya, masih boleh pakai lagi ke connection ni? Boleh pakai lagi tak? Satu series dalam 2 parallel. Boleh pakai lagi tak?
Boleh
Soalan
sir.
saya. Boleh? Okey. Sekejap. Tak apalah. Saya jawab sendiri lah boleh. Saya jawab sendiri. Soalan saya mulakan. Okey, kena. Okey. Ni kena dengar, you need to listen very careful. Okay. For this case, our VMPP for our module is 16 volt. Okay. And then I changed the question. I said that our SV, supervisor, system voltage is 24 volt. Okay. From here, means that VMPP kita tu lebih kecil daripada SB, betul tak? Betul tak? 16 volt lebih kecil
betul,
daripada 24 volt. Okey. Adakah valid lagi sambungan ini? Itu soalan saya. Valid lagi tak?
Tak valid. Dia
Ke
sebab
tak
dia
boleh?
kena kecil
Tak boleh. Kenapa tak boleh?
Dia kecil. Dia kena kurang.
Okey. Sebab dia kurang. So bila dia kurang, dia tak boleh nak charge bateri 24 volt tu. Dia tak boleh nak charge. Dia tak boleh nak regulate. Okey lah, kau mungkin pakai step up transformer, tapi kita tak ada step up converter apa semua tak ada ni. Kita tak ada boost converter apa kita nak boost. So kita memang original like this, so means that tak boleh lah. Arrangement ni tak boleh. Arrangement yang sepatutnya dia akan jadi 2 darab 1. Yang baru akan jadi 2 series darab Allah. Dia dah start dah sambung-sambung dia ni. Stress ke?
Dia macam nisbah sir.
Ulang balik?
Dia macam nisbah gitu. Berubah.
Dia masih ulang balik, tak dengar, tak jelas. Tengok saya.
Dia macam nisbah. Tak dengar
Dia macam rebound. Susah perkataan kau ni, aku tak faham.
Dua pen.
Okay. Maksudnya kita kena, okay. Saya mungkin soalan saya menilukan. Okay, lagi sekali. Maksudnya in this case we cannot do the one series darab 2 parallel. Sebab tadi kita kena voltage kita tu kita kena sambung modul tu secara series. Bila kita sambung secara series, dia akan jadi 32, betul tak? 32 volt. Oh. Dia dah start dah. Dah mula dah. Okay. 32 volt. Sambung 2 sambung 2. Sambung 2 dia akan jadi 32 volt. And then bolehlah kita charge bateri 24. Boleh regulate dari 24. Tapi connection sekarang bukan lagi 1 darab 2. Dia akan jadi 2 darab 1. Kenapa 2 darab 1? Sebab modul kita ada 2 je. Power kita still sama. Kita assume lah sama 200 watt. Sebenarnya dia akan soalan yang lain. Tapi tak apa. Still lagi 2 je kita ada. Jadi kita series kan. Sebab panel voltage kita tu tak cukup kan untuk charge bateri. Dia kena mesti it must be greater than the system voltage. Panel voltage must be greater than the system voltage. Baru the battery can be charged. So means the connection is valid. So dekat sini dia tukar 2 series darab 1 parallel. Kalau saya tukar soalan lah. Ada soalan Aisyah? Faham tak Aisyah?
Faham sir.
Boleh Boleh faham Fatin Kristina, boleh? Boleh faham?
Boleh sir.
Boleh aja. Okay. Kita move on Kita move on. Okay. Itu that's about panel lah. Solar panel. That's why it's very important lah. If for example we have 100 watts if we don't calculate the panel voltage based on our demand, we are going to have a very big problem where our battery can't be fully charged until many years. If we don't consider the size of the module tu, tak kira, we don't consider the panel voltage, the panel size with the energy demand that we want to use, you're going to face the problem where your battery will not be fully charged even for a year. Takkan dapat full charge bateri tu. Sebab panel voltage itu sendiri tidak mampu untuk charge. Plus if the wrong use of the system voltage macam tadi, our system voltage 24 volts but you connect in parallel because your mind thinking that I need to charge my battery very well. Means we need to amplify the current, sambung parallel, then you are going to get the higher current kan, higher charging current. Betul, that's right. But the problem is the system voltage tu. If the system voltage 24 volt and your panel voltage is 16 volt, you cannot charge. Whatever it is, you cannot charge. Maybe we can charge but maybe not move. Certain system will not work. Charge controller will not work because we need to you need to have the input voltage more than the battery voltage or the system voltage. That's why that's one sebenarnya. This is one of the reason why the battery is not fully charged, especially during the rainy days, and at the end shutdown. Battery shutdown. Oh, kata tak cukup battery tak cukup power. It's not the battery tak cukup power. It's actually that we are overuse the capacity of the battery one, and we don't have enough input voltage from the panel to charge our battery. Itu mindset kena ada. Ni that's the difference between you after you finish this class, at least you know lah this logic ke saya rasa macam tu lah, ilmu lah kot, this knowledge at least you have to have in your mind lah. If you don't you don't have this kind of thinking, this kind of knowledge, you just connect everything you have. How many panel you have? Okay, it's okay. Just put it together parallel. Battery. How much battery? Just put parallel because you need the higher capacity, and that's why we are doing parallel. Capacity tu akan multiply. Okay, but the battery, the panel itself, you use the 100 watts, but your capacity 100 Ah for example. Mana boleh charge? No. Tak sempat lah daya. While charging, you also using. Memang tak sempat lah. Memang buat design macam mana pun, tuanglah duit banyak mana pun, pakailah aircon lah, 1 horsepower macam beli macam nak bagi gempak kan. Tapi at the end, you don't know this kind of knowledge, it's a waste. Macam itulah. So dengan harapan, after this class, we are not going to do that mistake lah. Okay, choice of battery will be limited by what is on the market and how much you have to spend. Ini memang sangat subjektif. Battery, of course, sometimes before one of the problem for the standalone, like I told you, there's two things here, but the most expensive one is the batteries, the storage batteries. Because the storage batteries is the main component actually for the PV. Even though you get the energy from the sunlight through the PV panel, of course we need the PV panel for sure. If you change the PV panel with the wind turbine, it becomes a wind energy. But because we have the PV module or PV module ke PV panel, the actual pronunciation is PV module lah, the correct one. PV module, then you are going to extract, absorb, the silicon, everything, the material will absorb the energy, and then you get the photovoltaic energy kan. But that one, if you check the price also, the price is decreasing. While the capacity is getting higher, but the price is reducing. Very competitive now. Sangat murah. Macam saya tengok 450 watt, saya rasa RM700 ke boleh jumpa, boleh dapat. 450 watt. Gila kan? Murah. Dah makin murah. But the battery still lagi, that's one of the problem lah. Yeah, of course. You can buy the 100 AGM battery, if not mistaken, within RM900 boleh dapat kot. 100 ataupun murah lagi, 800 lebih pun boleh. Tengok brand juga. but people maybe go to the lithium ion phosphate, apa tak nama dia, saya pun tak ingat. Yang tu lebih DOD dia lebih besar lah. Okay, but the price is slightly higher than the lead acid. Okay, identify the available battery list important characteristic that can fit within your budget. Ini that's one when you choose to install the solar system in your house, small solar system, that you need to think about the price, the market, data sheet, everything lah. You pun start Google Alibaba, AliExpress, segala macam Shopee apa semua. Kedai memang mahal, memang online lah yang murah lah. Secara jujurnya, online memang murah lagi. Calculate the required capacity of your battery. The capacity of the battery required depends on 3 primary factors. The daily system charge requirement, okay, ini yang tadi kita kira. We need to know the required capacity of your battery based on the factors below. Apa dia? Daily system charge requirement yang kita kira tadi, how many AH that we need for our system per day. That's very, very important, that one. Okay? And that actually derive from the energy demand, relate dengan energy demand tu. Nak tak nak, memang based on energy demand. Once you increase your energy demand, everything need to be changed. Maybe. Tambah aja, tambah aircon lah, tambah 0.5 horsepower of the air conditioner portable. Yang tu memang kena revise balik. Everything must be revised. Sebab the energy demand already change and the daily charge requirement also change. And then also for the panel voltage pun change lagi. Kena tambah lagi macam tu. And the max, that's one thing. The max, second one is the maximum allowable depth of discharge factor. We call that as DOD. DOD, This is the deepest depth of discharge that is ordinarily allowed with the battery. Shallow cycle batteries, for example, should not be cycled below 20% depth of discharge, while deep discharge batteries can regularly handle 50% discharge, or kita panggil sebagai deep cycle. Remember, deep cycle battery, solar battery ataupun battery lori kot, battery lori yang pakai. But another lead acid yang motor, kereta, that one I think 20%, very shallow, very shallow. Depth of discharge ni dia punya dalam boleh begitu. Okay. In other words, if we say 50% of the discharge, even though 1 AH, ni senang nak bagi faham, 100 AH of battery, you use deep cycles. Actually, it's not 1 AH, it's actually only half. Because 50% consider, it's actually we can consider only 50 AH. For the deep cycle lead acid battery, typical case, 50 to 60, I think 50 lah. Sebenarnya separuh daripada AH yang you nampak dekat luar tu. Okay, 100 AH dekat luar, kotak luar tu kan. It's actually it's not there. If you think you get 100 AH, that is the big mistake. You need to think it's actually half of that. Dia mungkin boleh push lebih sikit, tapi kena ada mindset macam tu. Okay, battery 1 AH pun 50 AH sebenarnya. Macam tu. Okay. This one for the case of VRLA, valve regulated lead acid, or the deep cycle lead acid battery, or for AGM, I think AGM slightly higher than that, maybe 60 maybe. Depends on the data sheet tadi lah. Tapi in by default dia macam tu lah, the way of thinking. Don't use the car battery or the motorcycle battery, that is the worst lah. But if you try to buy in the internet, I'm not promoting, for example GP battery kan, tu memang common boleh nampak lah, GP battery, yang best ni kadang-kadang ada hijau, kadang-kadang ada hitam. Ada hitam tu kan, so that one is the deep cycle one lah, deep cycle. Bukan bateri motor Koyoko apa semua tu kan, Hitachi apa semua, tu bukan, tu memang tak tahan. Yalah mungkin of course you can use in your car for the system, apa PA system lah, sound system lah, LCD, Android player, that one because they are keep charging, the battery is keep charging because of the your start your engine and battery also keep charging kan, that's no problem lah. But kalau nak guna high capacity tu pakai yang ni lah, 50Ah ni, usually for the solar battery lah. Okay, other thing, reserve storage factor or the number of days of storage needed system autonomy. Okay, yang mula-mula kita nampak autonomy days kan. this varies with site and is higher for site with cloudy weather. Yang inilah number of days of storage. Just now, the daily charge requirement tu per day, AH per day. Let's say you want your battery, this unit, based on your desire, you want to, your system can withstand for 2 to 3 days. So you need to multiply with 2-3 days. So if you multiply with 2 or 3 days means you need to have 2 or 3 times higher capacity of the battery compared than only consider for 1 day. Faham kan? If you want to use for 3 days, so you kena kali 3 lah. Kali 3 punya battery capacity, more money lah. More money will be spent for that. Okay? So that's the thing. Okay? So, for the case of battery sizing and selection, still the same minimum number. Okay, we are going to say minimum. This time for standalone, everything must be minimum lah, because you need to fulfill that minimum requirement of the energy. If they don't satisfy that requirement, so all your loads cannot be used as your expectation. Okay, so C battery, Allah terbang dia. Okay, but saying this the battery requirement, charge battery requirement. Okay, system. Oh sorry, ni ada term kat sini. Required capacity, required battery capacity for your system. Okay, first of all, don't forget the energy demand and don't forget the system voltage is if 12 lah, if 24 and the DOD max. In the question I will give you the DOD, depends on the, but for the lead acid typical value, typically for lead acid, you can say 50% only. Then T raised days is the reserve storage factor system autonomous. So how many days you want system to withstand? For example, you want to use the, for example, small PA system for the campsite for a week. Week means 7 days. So you need to have the multiply with 7 lah, means that kali 7 pula. Okay, kali 7. Okay. And then, so you are going to get the required battery capacity. Total required battery capacity to how many AH. And then, next is the, it's 1, 2, N battery parallel. So parallel connection of the battery. C battery requirement. From here. Okay, from here, you divide into the C battery is the capacity of the battery. For example, we have the battery of 100 AH and 100 AH. Then total battery requirement capacity kita kira tu bagi dengan berapa AH tu. So that one maybe you can dapat lah. Contoh, you are going to need this one 600 AH. For example, 600 AH. And your battery is 100 AH, means that you're going to need 6 pieces of module in parallel. So you kena ada 6 kali lah. Capacity tu you need to amplify kan. So means it will be parallelized. So you akan parallelkan 6 ke bawah. Untuk to achieve that required capacity. That's the one thing. Okay. What's next? Next is the system voltage. Okay, system voltage ni depends lah. Our system, just now we have 12 volt. Maybe sometime we have 24 volts. Then, usually battery by default is 20 volt. Jarang lah saya nampak battery 24. Ada. Tapi di sini actually they are connected in series already. But most cases in the market, in the internet, in the website, everything in the car ataupun mana-mana kedai lah. Usually battery yang kita ada di acid tu 12 volt base. 12 volt base. So, if we have 24 volt, then 24 over 12, dia akan dapat apa? Dapat 2. So, sepatutnya 2 series. This is also the mistake for the newbies. Bukan newbies, for those who doesn't know anything about this. they just take the small battery 12 volt, then parallel. Okay, we get the capacity. Yes, capacity you get, but you don't get the system voltage. Ini lagi parok kalau 48 volt. 48 volt, you are going to need 4 pieces of series batteries. 4 pieces. Kena ada 4 lah. Okay. Let's say charge requirement tadi kita kena ada 6 parallel. Kau bayangkan 6 parallel. 6 parallel, 4 pieces in series. Tu dia, dalam ke 6 dalam 6 multiplied with 4, 24 batteries. This is what I mean before. It's all about the cost for the batteries. Memang sebiji bateri tu pun mahal juga kan. 1 mAh dalam RM850 for example lah. Di acid. Kalau AGM base kan. Gel punya kan. Eja cari kau jumpa lah satu tu 800. Tapi itu kalau sebiji. Kalau sistem voltage load kau guna banyak, then kalau perlukan 24 dah 2 biji series, then tak cukup parallel. Kau nak tahan sampai seminggu. Tahan sampai seminggu pakai sebiji memang tak dapat lah. Means you need to have the more battery that will be connected in parallel. So when you connect in parallel, dia kena ada yang lain juga. Faham tak? Contoh, biasanya kita punya sistem tu 4 in series lah. 48 volt. Macam ini kan, 48 volt. And then you are going to need 6. Okay lah, saya buat tak cukup 6. 5 lah. Ni bukan mata 4 lah. Ni bukan mata you nak 4 capacity ni sebab you nak 4C. You nak, for example, 100Ah, so you need 400Ah of the battery capacity. That's why you parallelkan untuk dapat 400. Okay, faham? Then you need series of 4 because you need to provide the system voltage of 48 volt. Okay. Don't forget ni Don't forget this one this one. Yang ni yang tak tahan ni. Yang ini yang problem ni. You kena ada lagi 9 sebenarnya. Ada 9 pula, so in total you are going to get 16. So this is where all your money will go. Will go. Kat sini yang budget bateri. Panel tadi mungkin tak banyak kan. Kau beli yang 500 watt, kau beli 4 biji pun baru berapa ribu. Contoh tadi saya dapat 700. 7 darab 4. 2,800, you're going to get 500 watts. 4 pieces of 500 watt solar module, which is you are going to get 2 kilowatts of the generated panel tu. You dapat 2 kilowatt. Power lah 2,800. Bateri kalau sebiji 800. 800 10 sudah 8,000. 10 kan. Yang atas ni perlukan 24. 8,000 untuk sebiji 800. 10 8,000. 20 nangis. 20 dah 16k. And then another 4 multiplied with 8, 3,200 ringgit. So you're going to get 19,200k ringgit Malaysia for battery only. Yang itulah yang menjadikannya saya sampai sekarang until now I haven't installed yet. I haven't installed yet. Duk fikir benda ni cost ni, bateri ni tak tahan. Yang ni yang tak tahan ni. Inverter is not that much the price. Even you buy recently they have the what you call that they ada hybrid inverter that can 4 kilowatt system, 2 kilowatt system besar. 2 kilowatt, 4 kilowatt, I think maybe 1,000 something or 2,000 only lah for the inverter plus charge controller. Ada dua-dua terus. So tak payah fikir charge controller separately buy. You have one set, we call that hybrid inverter kat maybe. Hybrid inverter dia ada charge controller dah siap dengan inverter. Selesai. Saya ada sama genset lagi. Selesai kan. Tapi bateri is the problem lah. Okay, battery is the problem. See, this is the reason why until now I haven't spent yet for this. Even nak buat juga kan. Nak buat juga, lepas tu nak belagak bragging kan budak kan. Baru jadi modal kan. Sembang tu cerita dia sebenarnya. Any question? Boleh faham tak? Untuk saya cakap seorang-seorang saja. Syafiq. Muhammad Syafiq.
Ya, sir.
Faham? Boleh faham?
Faham je.
Faham lah. Ya, faham lah. Boleh dapat idea kan? Dapat idea kan? Apa sebab musababnya? Kenapa sampai sekarang saya kemut lagi? Duk fikir betul lah. Modal tu. Nama Tanyason.
Faham.
Understand? Boleh?
Boleh.
Boleh dapat Okay. Soalan lagi tanya. Anutra. Anutra tak ada. Anisha.
Setakat ni tak ada apa-apa soalan.
Nak tidur. Ada orang. Okay. Okay lah, saya proceed sikit lagi. Sikit je. Okay. Mari kita bershopping. Okay. Design example. Battery sizing. Let's say we have this kind of battery with depth of discharge 60%, and then battery voltage 12 volts, and the battery capacity is 21 Ah. Okay, 21 Ah. Then, so minimum battery capacity. Okay, battery capacity yang just now we have calculated already. Let's say we have same 745. Then the DOD already mentioned before in datasheet of the battery, 60% or 0.6, and then system voltage we know already is 12 volts. Then assume that we need the system to withstand for 2 days. Okay, 2 days. Then we multiply with 2. Then you're going to get to 207 Ah of the total minimum charge capacity that we need for our battery storage batteries. Okay. Then from there, then we can easily calculate number of batteries in series. Okay, number of batteries in series, because we are using SV over C battery. SV12, C battery 12, so 1 of 12 volt battery. So means only one lah. We don't need until 4 in series, because we use only 12 volts. It's enough for only 1 pieces of battery in series. And then what about the number of battery in parallel? This is how the total charge capacity is play with here. So 207 over the capacity of the battery that we choose. For example, for this case, we use 21 Ah. So we are going to get 9.85. Same, we are going to round up. Round up because minimum. For the standalone case, everything is minimum. So when everything is minimum, everything must be round up. So that's why we get 10 batteries in parallel. So the number of batteries or the arrangement, the configuration of the battery for this system is 1 in series. 1 in series and 10 in parallel. So total you are going to need 10 pieces of 21 Ah battery for our system, for this example lah. Boleh faham? Siapa seorang dia saya tanya? Sekejap. Wait, tadi pun. Pei Yilin.
Yes, sir.
Understand? Boleh?
Boleh.
Boleh, okay. Okay, sikit lagi. Okay. Configuration of your battery set. Battery should be configured at the system voltage. Make a drawing of your battery configuration. Small of grade PV system usually. Ingat most cases 12 volt DC. Ini memang untuk level household ataupun simple level. But if 2 volt DC or 6 volt DC battery are used, they are configured in series so that the total equals to 10 volt. Okay. Mungkin awak pelik 12 volt. Okay, 2 volt. Memang ada 2 volt. Dia memang kalau memang kita panggil storage banks, battery usually they use the 2 volt battery not 12 volt. 12 volt ni kita guna sekarang sebab cost dia. Tapi untuk mega scale storage banks, kalau untuk microgrid system ke, they use 2 volt. 2 volt ni kalau ikut logik ni lagi membazir lah kan. Sebab kalau kita nak fulfill 12 volt tu kita kena ada 6 biji lagi pula. Serius kan? Betul. Tapi biasanya yang this 2 volt ni bateri dia sangatlah besar, dia punya capacity. Saya difahamkan ada yang 25,000 Ah 25,000 AH capacity but the voltage is 12 volts. Capacity dia bapak gajah. Bateri dia salah saya tinggi semeter ke. Macam itulah. Berat nak mampu. Macam tu lah. Jangan tinggi apa. 2 volt ingat bateri kecil bukan? Bukan bateri kecil. Memang kalau storage banks, you boleh google pun. Even Tesla ni bateri ke apa benda, you google je. You memang akan nampak yang memang capacity malah dia lebih besar daripada ni pun. Capacity very high capacity but the voltage is only 2 volts. Okay? Only 2 volts. Itu memang besar untuk capacity. Sebab kalau dia ada higher capacity than 12 volts, nanti dia punya decrement tu lagi critical sebenarnya. Decrement tu lagi critical. Sebab 12 volt kan, if dia become 10 volt, sakit lah. Tapi kalau 2 volt jadi 1.8, 1% dia tak affect the whole system kan. So dia punya degradation pun lebih bagus. Okay, degradation rate dia lebih rendah berbanding dengan 12 volt. 12 volt tu boleh, kalau bateri yang kong kan, kalau dia perasan bateri yang kong boleh tu sampai 3 volt kan. Paling kong lah, 5, kadang 9, 10 kan. Tapi untuk kes ni mungkin 2 sampai 1.8 ke, itu mesti boleh guna lagi kan. Itu maksudnya. Okay, before choosing charge controller, decide the controller size current setting. Ini CC ataupun charge controller. Okay, selection of the inverter and charge controller. Okay, charge controller. Controller need to be sized according to the system voltage. Remember, I already mentioned before, 12, 24, 48. Make sure you don't make mistake. Because I have made mistake before. Kadang Shopee dia ada klik-klik kan, 12 volt, 24, 48 kan. Saya tak perasan ada button-button tu. Saya ingat dia fleksibel. So saya pun biar saja. Tapi at the end, rupanya saya terbeli 24 volt. So bila sama bateri biasa, kenapa tak gerak-gerak? Bila tengok rated, 24 volt aku beli. Tapi tak boleh return dah, undetectable. Macam itulah. Don't make mistake lah. There's some inverter or the charge controller they are flexible. 12, 24, 48 they can do. But there's some inverter also dedicated only for 20 volt only. So make sure you read the terms and condition very careful before you decide to buy. Okay. Dah aku 3.20. Okay. Controller must be sized to handle both the maximum short circuit current from the array and the maximum demand of the load. Okay. The purpose of the controller, charge controller tu tujuan dia apa, ingat tak? Charge controller, the main important function of the charge controller is to control overcharge and over discharge. That's the main important things is to prevent the batteries from overcharge or undercharge. Overcharge or undercharge. Over discharge, overcharge or over discharge. Tu the main important of the charge controller. So that's you are not going to destroy your batteries and if you don't use the charge controller, while using the load, it will not stop until explode. Macam tu. But if you use charge controller, the charge controller will automatically stop when the battery voltage reach certain values. Okay, kita boleh set the cut off. Okay, so charge controller also need to handle both maximum short circuit current from the module, maximum short circuit current daripada module, and also maximum demand of the load. So that's the important. Dia ada dua laluan lah. Charge controller tengah-tengah. Input dan output. Dia control input dan output. Okay. So second sizing memang boleh besar 5 to 550 actually until 100 depends on the brand. Okay. Many charge controller, if they say 10 amps charge controller mean 10 in, 10 out. That's easy. 30 means 30 in input current from the module and 30 output current to the load. Okay. To determine the array's current size, calculate the maximum short circuit current of the array and multiply it by 1.25. Okay. Tadi kita tengok short circuit current. Kita will be based on the short circuit current of the module, not the IMP of the current, but it depends on the short circuit current of the module. From there, okay, short circuit current tu you multiply with the 1.25. So kena multiply with 1.25 means if you have the 10 amps, you cannot get the input current exactly 10 amps masuk dekat charge controller. Tak boleh lah. Dia patut kecil lagi. Dia patutnya selepas didarab dengan 1.25 X, darab 1.25, 10 amps. Maksudnya tu. So maksudnya modul X tu sama dengan berapa? Kau kira sendirilah kan. 2.5 mungkin 6 kot. 6, 2.5, 8. Okay, 8 darab 1.25 sama dengan 10 amps. So maksimum sebenarnya short circuit current untuk modul tu adalah 8 amps, for example. Okay. That determine maximum current load, blah blah blah, maximum power consumption of all DC not AC appliances. Divide this by the system voltage to get the maximum DC load and multiply by 1.25. Okay. Kira. You boleh kira. Okay. Yang ni, ni apa? Cerita siapa? Okay, ni VMP, ni maximum voltage yang boleh ditahan oleh charge controller ni. Dia ada tulis lah. And the maximum current is 10 amps and the maximum voltage is 60. And this is the system voltage. For this charge controller, it can by channel dua channel. Dia ada 12 volt and 24 volt. You don't have to switch on and off. No need. They will automatically detect when you connect battery in two series. The battery is connected into series and two series kan, and it automatically will detect 24. It will also operate. Okay. Then MPPT, yes. Okay, ni yang contoh contoh yang ada MPPT lagi. And then selection of the inverter. Okay, selection inverter is an inverter needed. The inverter must deliver the maximum AC load. Then you expect total up the power of the AC device and multiply this by 1.25. Total up the power AC device. Total up berapa? Multiply with 1.25, itu adalah recommended inverter rating. Contoh, you ada 1 kilowatt of system. Total up semua modul-modul dia tu ada 1 kilowatt. So you darab dengan 1.25 tu, dia akan jadi 1250 watt. So you buy lah inverter yang besar lagi daripada tu. Macam tu, secara konsep yang guna. Bukan macamnya 1 kilowatt, you use 1 kilowatt. No, you need to have the margin, that 25% margin. So again, if 1000 watt system, then you need to multiply 1.25, means it becomes 1250 watt rated inverter you should buy. Okay, and then select desired, decide the design features and the blah blah blah. Make sure wave shape of the inverter match the needs of your appliance that I told you. Please find the pure sine wave inverter. Ni the worst wording lah before you buy inverter yang murah-murah tu, the cheaper one in the online. So please find this pure sine wave inverter. Don't buy the solar car inverter. No. This one I think I strongly believe that is totally 100% not the pure sine wave. At least you find for the pure sine wave inverter. Apa maksud pure sine wave inverter? Hampa Google lah maksudnya. Okay. So example, inverter sizing efficiency is written here 90%, but to be honest, if you try to find the online, usually looks like this value is not given. But if the proper one, sometimes they write. Okay, operational voltage only 24. This one may be only dedicated for 24. It cannot be 12. It's not by channel. Okay, it's only 124. That's why you need to be very careful. Don't make mistake like me. Okay. Minimum nominal power rating for the inverter 200 watts and you over the 0.9 watt, so minimum nominal power rating is actually 222.2 watt lah, even though they write 1500 ke, actually it's not the 1500 punya system lah, sebab consider the inverter efficiency. Okay, alright, ni dah last kot. Okay, last. So this is the last slide. Saya nak sambung. Saya nak ajar awak sambung. Because we don't have the physical, we don't have anymore the physical one, so we only have one chapter after this, and then after chapter maybe some revision again after that. Saya plan nak ajar you PVCs tu, tapi tengok macam mana keadaan. So ini adalah, so this the within this week I will release the assignment. Okay, assignment will be released. Okay. It's just the practical, but in theory one in digital, virtual lah. It's not exactly in front of you. Because it's very difficult for us to have the physical contact anymore. Okay. Example of the charge controller. So this is the charge controller. Bad. Okay. I know panggil sudah. Okay. Alright. So this is charge controller. Ini charge controller CC. Usually there will be 6 holes with screws here. 1, 2, 3, 4, 5, 6. They have 6 holes. Dekat sini ada tulis sebenarnya. Yang ni kalau tengok betul yang ni. The first 2 one is the modules. Ni modules ni. Betul sini. The second 2 second 2 holes is for battery. Battery sama sini. 2 ni Ni battery. And the other 2 is for the DC load. This is for DC load lah. DC load kan. Because direct DC. Okay. So, if I'm not mistaken lah, usually the arrangement, they are written there actually. Plus, minus, plus, minus, plus, minus. Macam itulah. Plus, minus, plus, minus, plus, minus. So, modul kita ni memang ada plus dan minus. So, cara dia sub. Okay, plus. Dan ini sambunglah sini. Saya meletak dia. Dia sebenarnya sambunglah dengan kabel belakang tu kan. So, itulah sambungan dia. Charge controller dengan yang ni. Okay. This is the, I'm just showing you the very basic connection. The real one, you need to put fuse. Kena ada fuse kat sini. I heard it's not necessary anymore to put both fuse for plus dan minus. Tapi tak apalah, saya letak juga. Saya tak kira. Saya letak juga. Dua-dua ada fuse. Plus dan minus. Okay. You want to put the, if you still remember, we have the, what we call that, blocking diode. Kita ada blocking diode kan? Blocking diode. Tak sini pun boleh. Kalau nak letak blocking diode. Dari sini. Okay. So that there will be no reverse current. During the night, the battery will not be reversed. The current from the battery will not be reversed to the module. That's why we need the blocking diode. Okay. Alright. What's next? Okay, what's next is a battery. Battery merah tu kan positif. So kita pun sambung positif sini. Yang ini kita sambung ke negatif. Okay, negatif. Okay. Kabel. Okay. Kabel ni berapa biasa? Macam by default, I think 50 watt and above or 100 watt and above lah. Mostly the solar cable given attached at the back is 4 meter square of the solar cable usually for this cable. Okay. Okay. For the battery cable, if not mistaken, ni tak confident lah. 6.0 or 10.0 lah. I don't know lah. Untuk battery cable. Okay, wire untuk cable untuk battery. Cable battery. Okay, battery cable. Alright. Then also again, here actually you need to letak MCB lah, not the fuse, but you put the DC MCB. MCB lah, miniature circuit breaker. DC MCB, both. Okay, both plus and minus. Okay, letak DC MCB. Okay, if you don't have the DC MCB, you can put the AC MCB, but that AC MCB maybe if something happen, it will not trip. DC dia akan trip dengan DC lah. But okay lah, at least kita boleh switch on off kan, in case lah. Sebab masa you nak sambung connect that I told you, the most sensitive part is to connect the battery. Sometimes you just connect in the charge controller, sometimes there comes spark. Kadang-kadang ada spark. Especially when you try to connect a lot of things, when you try to connect it parallel series, that one very challenging lah. Within the cable. If you ask me, between the cable, all the cable series and parallel tu betternya lah, bagi saya lah, betternya kalau letak satu circuit breaker tu lebih safety, tapi nampak orang tak pasang tu. Dia kalau satu channel panjang tu baru dia pakai. Dia buat satu series panjang kan, and then baru dia ada circuit breaker tu lah, kalau buat series semua kan. Tapi when we start to connect in parallel, when you try to connect more than one battery, there's the possibility of spark or make mistake, touch, short skirt. So yang itu agak critical. Sebab tu that's why I told you, one of the safety tu pakai glove yang apa nama tu, rubber made or the clothes made, Insulin is insulated. And then the bolt also, even though you pakai glove tu, kat bolt tu pun kalau you letak tape hitam tu kan, tu lebih totally kita nak eliminate any possibility lah. Any possibility. Lepas tu lagi bagus ni dekat terminal tu pun kau tape dulu. Selagi kau tak pasang, kau letak tape supaya tak bersentuhan. Bila you start to connect more than one battery, dia akan jadi macam tu. Dia akan jadi macam tu. Possibility tersentuh lah, apa benda lah, tershort, itu memang berlaku banyak lah. Okay. Alright. So that's finished for the panel. Input for the panel, and then the output to the battery. Okay. And then this one is DC I told you kan. Okay. Yang ni, okay lah. Let's say we are going to have, saya tunjuklah contoh ni secara theoretical lah, secara theoretical. Yang lain kau kena buat sendiri lah kan. Yang ni pun, let's say lah, you are going to put switch. Okay. You nak ada switch, tekan-tekan untuk 4 lampu berbeza kan. Jadi dengan ini, kau pun ambil lah positif ni, kau pasang sini positif kan. Positif aja kan. Lepas tu kau pun tak tahulah ada switch satu ni kan. Switch sama sini. Lepas tu sama sini. Tapi ni remember lah, ni DC penyebab lah. Lepas tu letaklah switch ni petik-petik kan, tak kisahlah switch apa. Pada kabel plus. Okay, switch lah. Oh, switch patut macam ni kan. Tak lah, boleh lah. Switch connect sini. And then the negative one saya rasa semua boleh di loop kan. Loop kan. Loop belakang. Loop. So boleh, tak masalah. Yang penting connect to positive tu ada switch dalam dia. So ini semua sambung dekat sini. Okay. Nak selamat lagi satu, yang dekat ujung ni kau letaklah DC MCB. Okay, DC MCB. Yang ni pun ada DC MCB for both sides. Both side. Oh, saya terlupa. Sorry, saya terlupa. SPD. Oh, lupa. Sepatutnya cakap tadi, dia patut ada SPD ke. SPD tu kau sambung 3 terminal kan. SPD ni ada 3 terminal, ni SPD. SPD ni kita parallelkan. SPD ni ada 3. Satu dia akan jadi negatif. Plus negatif, lepas tu plus grounding, negatif grounding. Grounding tu tahu kan? Grounding ni biasanya orang tebuk dekat panel tepi ni. Dia tebuk tarik keluar. Tebuk tarik keluar, di grounding kan. So yang wire ni lah yang kau sambung dekat SPD tu. Macam tu lah lebih kurang. Okay, ingat kan aluminium frame of the module is the made by the aluminium. Usually they put holes. Sometimes they have holes already, then they put the screw there and you pull out the cable. Pull out the cable, the green cable lah, to the ground, to the copper rod yang dalam tu. Okay, tu bukan tu yang lain pula lah. So grounding. Okay. Ini biasanya DC LED biasa ni dia tak ada grounding kan, dia memang plus dan minus. Boleh dengar cakap saya? Boleh dengar saya tak? Ke saya cakap seorang ni?
Boleh saya.
Boleh kan? Boleh fokus kan? Yang ni bagi saya ni penting secara theoretical lah, tapi itulah for the safety don't forget the DC MCB lah. Okay, boleh guna AC MCB as the switch off dulu kan, supaya nanti you sambung tu tak ada spark, tak ada berlaku apa-apa. Okay, kita ada inverter. And then inverter. So inverter ni, okay, dia ada beberapa filosofi sebenarnya. Ada yang ada yang sambung direct kepada bateri, tapi dia ada breaker lain. Dia ada breaker lain. Tapi for the sake of the safety, everything should be sini lah. So dia patut dia parallel ke sini. Ni. Positif masuk ni. Positif. Lepas tu parallel lah. Ni pun negatif. Same safety, letaklah DC MCB lagi sekali. Ni DC MCB, ni pun DC MCB. Okay, MCB tu kita letak sebagai switch. Okay. Then ini output dia, barulah sambung kepada all our. Okay lah, aku nak letak plug kan. Tak plug, nak pasang TV dengan desktop. Pasang sini lah. So ni mungkin ada grounding ni kan. Rasanya ini pun sama juga. Biasanya orang tebuk ni ataupun dia ada grounding, wire grounding ni kan. Grounding kan. Yang grounding ni semua kau grounding kat tempat yang sama. Okay. Grounding tempat yang sama. Betul. Inilah konsep dia. Dia kurang. Okay. Then you can check lah the fuse, the DCMCB, the SPD, surge protection device, DC miniature circuit breaker, all that things you need to check it. We check in. So that make sure if you want to plan, itulah macam saya cakap tadi, sometimes you can put the DC fan. Recently we had the DC fan, korang DC fan. DC fan. Sometimes dia ada aircon, DC cooling system. We try to do the DC also. For me, if you DC, we can eliminate the efficiency that coming from here. Ni ada loss kan. Ni kan ada loss dia. Bila kita convert AC tu dia ada loss dia. Macam 90%, 55% apa. 85%, 80%. So that's the loss there. Kalau boleh guna DC semua, all can be DC, better lah. Kalau untuk yang remote place punya kan, untuk camping kan, you pakai DC je lah. Avoid lah guna AC tu. Even you want to charge your battery also, dekat ni ada ni. Ni ada 5 volt. Dia dah regulate dah. 5 volt untuk USB. USB punya ada. Biasanya dekat yang charge controller tu dah ada banyak dah. 1, 2, 3, 4 dah ada dah. Boleh charge bateri kat situ. So kita nak survive kat luar kan. We have battery, we have phone, smartphone okey dah kan. So berpada-pada lah. Macam tu lah. Okay, ni question. Habis. Standard. Ini question. Ni boleh try lah kat rumah. Kalau if you have modal, some budget, you can try lah. You can try. Bagi saya it's quite interesting lah. Bagi saya lah. Cuma saya tak properly buat lagi. Duk kira pasal bateri ini, bateri. Saya ada load saya kan. Contohnya kita memang nak guna aircon. Aircon yang of course 1 horsepower is difficult. Maybe we can have the 0.5 horsepower. We want to use the aircon unlimitedly. But at the same time, the battery also will play the role, and the module. We need also to use for other things then outside kan, bab-bab yang keluar tu. Kat situlah masih lagi perkiraan saya lah. Kalau boleh guna 0.5 horsepower aircon tu steady for several hours, will stand steady. Any question? Question? Puasan tinggal 9 orang dah lari. 10 orang dah melarikan diri. Afiq pun dah tak ada. Cabut dah. Haziq.
Saya.
Ada soalan?
Tak ada saya.
Tak ada. Okey, boleh faham?
InsyaAllah boleh.
Boleh sambung dah lah kat rumah. Kalau ada duit. Khairul Nisa, okey Khairul Nisa.
Yes, sir.
Boleh faham ke dah tidur? Boleh
Boleh,
kan?
sir. Boleh.
Yeah. Okey. Seorang lagi lah. Ivan.
Yes, sir.
Boleh faham?
Okay.
Okay, kata apa-apa. So within this week I will release the assignment. Same group. So thank you. Okay. See you next week.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Alright.
Thank you, sir.
Thank you, sir.